Yeah, hello everyone. In this tutorial, we are going to discuss the quotient rule and how you can apply the quotient rule in solving your calculation questions under differential calculus. So now let's start from the representation because from the name itself, quotient, it means that there's going to be a division symbol. So and quotient rule is used when you are trying to find the derivative of the quotient of two functions, or let us say when two functions are dividing each other. So let's, if our two functions are u and v, so if we divide this function, we are going to have y is equal to u divided by v. So this represents the division of function u and function v. So let's add changing y and changing u and v to both sides. We are going to have y plus delta y is equal to u plus delta u divided by v plus delta v. So from here, y plus delta y will give us u plus delta u over v plus delta v. Now you might look at, okay, why am I rewriting what we have here? It's because I want to do something. Now, there's a concept in mathematics that we call rationalization. And the basic, when you're trying to rationalize something, you are trying to use the concept of difference of two square as the denominator, so that what you're going to have at the denominator is not going to be something that is a uh let me refer to it as a mixture. When I'm referring to it as a mixture, you know that if you have a compound sort, for example, let's say 1 plus root 2, if we are to rationalize, you multiply it by the conjugate, which simply means that your final answer, you're not going to have a surd, you're just going to have a real number. So you know that if you multiply this by the conjugate, which is 1 minus root 2, this then becomes difference of 2 square, a plus b times a minus b. So I want to use the same approach here. I'm going to multiply the numerator and the denominator by the conjugate of the denominator, which is v minus delta v. So this will be times v minus delta v divided by v minus delta v. So y plus delta y will give us u multiplied by v minus delta v plus delta u multiplied by v minus delta v divided by v times v, or let me just use difference of 2 square. A square, that will be v square minus delta v square. So what this means is that if we take, okay, before taking y to the other side, we can say y plus delta y will give us u times v, that's uv minus u delta v plus v delta u minus delta u delta v. Then everything is being divided by v square minus delta v raised to the power of 2. So what it then means is that if we take from here, if we take this y, if we take it to the other side, we will be left with changing y at the left hand side is equal to uv minus u delta v plus v delta u minus delta u delta v divided by, sorry, being divided by v square minus delta v square minus y. And that y is what? U over v. So that is minus u over v. So what this means is that delta y will give us a combined division sign if we take the LCM. the LCM of v and v squared minus delta v squared, that'll be the product. So that's v multiplied by v squared minus delta v squared. So everything here, or let me say v squared minus delta v squared in this, it remain v. So we are going to have v multiplied by uv minus u delta v plus v delta u minus delta u delta v. Don't forget there's a v outside here. Minus, now v in this, it remains v squared minus delta v squared. So using it to multiply this, let me extend the division sign here. So v in this is remain v squared minus delta v squared multiplied by u. So that will give us u multiplied by v squared minus delta v squared. So from here, delta y will give us v times uv will give us uv squared. Now v times minus u delta v will give us minus uv delta v plus that's v times v, that will give us v squared delta u. Now v times this, that will give us minus v delta u delta v minus u times v squared. This will give us uv squared plus minus u times minus times minus will give us plus. Now u times delta v square will give us u delta v square. So everything is still being divided by v over v square minus delta v all square. So delta y will give us uv square minus, let me put it to very well, uv square minus uv square, that will give us 0. So we'll be left with minus uv delta v plus v square delta u minus v delta u delta v plus u delta v square being divided by v into v square minus delta v raised to the power of 2. Okay, so uv square minus uv square, that's giving us 0 already. Now take a look at something. This v that we have at the denominator will be v raised to the power minus 1 multiplied by minus uv delta v plus v square delta u minus v delta u delta v plus u delta v raised to the power of 2. Now everything is being divided by now don't forget, it's this v that we took to the numerator that became v raised to the power minus 1. So at the denominator we'll just be left with v square minus delta v raised to the power of 2. So here delta y will give us, now v raised to the power minus 1 times this is going to cancel out this v, because v raised to the power minus 1 times v raised to the power 1 will be v raised to the power minus 1 plus 1, which is v raised to the power 0. So, or you can say v raised to the power minus 1 is the same thing as 1 over v. So when you say 1 over v times minus uv, it will still cancel out this v. So here we'll be left with minus u delta v plus, Of course, 1 over v times v squared, that will give us v delta u minus delta u delta v. The v will cancel this out also, plus u over v delta v square, which is going to be divided by v square minus delta v raised to power 2. So now let's divide through by delta x. Delta y over delta x will give us minus u delta v over delta x plus v delta u over delta x minus delta u delta v over delta x plus u over v delta v square over delta x. Now everything is being divided by v square over delta x minus delta v square over delta x. Now, after dividing through by delta x, the next step is that you take limit as delta x tends to 0 on both sides. So limit as delta x tends to 0, 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 limit as delta x tends to 0. So limit of delta y over delta x as delta x tends to 0 is equivalent to the y dx is equal to minus u is a constant, so we can factorize that out. Minus u, limit of delta v over delta x as delta x tends to 0 is the same thing as dv dx plus this v is a constant, so we can bring it out. V, limit of delta u over delta x as delta x tends to 0 is the same thing as du dx. Now, everything here has been divided by delta x, so they will all give you an undefined answer. So everything here is being divided by this v square is a constant, so we can factorize it out. Limit of delta x, limit of 1 over delta x as delta x tends to 0 is also going to be undefined. Now, limit of delta v square over delta x as delta x tends to 0 is also going to be undefined. So we are left with the y dx is now equal to, so if we bring this first before the minus sign, we are going to have v du dx minus u dv minus u dv dx, everything being divided by v square. So, and that gives us our quotient rule formula. So now let's take a sample question using the formula. Now let's assume a question. Let's say that we're given that y is equal to x squared plus 3 divided by 2x raised to power 2 minus 7. Find the y dx. So this is a function, this is another function, and they are dividing each other. So use the same concept. If our y is equal to u over v, the y dx will give us v du dx minus u dv dx divided by v square. So contrary to product rule, you can't say that your numerator must always be your u, your denominator must always be your v. You can't take it vice versa. And it's because division is not commutative. So the law of commutativity, that is under binary operations. And when you say 2 divided by 3, it's not the same thing as 3 divided by 2. But in terms of product rule, multiplication is commutative. When you say 2 times 3 is the same thing as 3 times 2. That's what the law of commutativity simply mean. And when you're dealing with binary operation, you'll have done things like A asterisk B will be equal to B asterisk A for that particular operation to be commutative. So now, if our U, we are taking our U to be the numerator, our U is equal to x squared plus 3 du dx. When you differentiate x squared, you get 2x. If you differentiate 3, you get 0. So our du dx will be 2x. So our v is equal to the denominator. Our v is equal to 2x squared minus 7 dv dx. Our dv dx is going to give us, if you differentiate 2x squared, you get 4x. If you differentiate minus 7, you get 0. So it means our dv dx here will give us 4x. So using the quotient rule formula, since our dy dx is equals v du dx minus u dv dx divided by v squared, our v here is 2x squared minus 7. So we have 2x squared minus 7 being multiplied by our du dx, that is x squared plus 3. X squared plus 3. Oh, sorry. Our du dx is not x squared plus 3. Our du dx is 2x. So this is being multiplied by 2x minus our u. Our u is x squared plus 3 multiplied by our dv dx. Our dv dx is 4x. So everything is being divided by v squared. Our v is 2x squared minus 7. So that will be 2x squared minus 7 raised to the power of 2. So it means that the y dx will give us 2x. We use 2x to multiply the bracket here. 2x times 2x squared, that will give us 4x raised to the power 3 minus 14x. So here we're going to use, it's not just minus 1 we're going to use to multiply here. We're going to use minus 1 times 4x, that's minus 4x. So we're going to use minus 4x to multiply the bracket here. So minus 4x times x squared, that will give us minus 4x raised to the power 3 minus 12x. So everything is being divided by 2x squared minus 7 raised to the power of 2. The y dx here is going to give us 4x raised to the power 3 minus 4x to the power 3 is 0. So we are left with minus 14x minus 12x, which will give us minus 26x divided by 2x squared minus 7 raised to the power 2. And this is going to be the final answer to this question. So this is all on quotient rule. See you in the next tutorial. This is Learn with Uncle T.